This is a continuation of our lecture series on vector valued functions, and now we are discussing about velocity, acceleration and speed of a moving particle. Suppose a curve C represents the path of a moving object. For example, if C represents the flight path of a plane. Then we can represent C by a vector function. Vector r of t is equal to f of t vector I plus g of t vector j plus h of t vector k, where t element of I. Here the parameter interval I is a time interval and r of t indicates the position of the plane at the time t. Here r of t gives the positions of the plane at time t. From the previous discussions we know that the vector r dash of t is tangent to C at P and modulus of vector r dash of t is equal to ds by dt. Since ds by dt is the rate of change of the distance with respect to time, it measures the speed of the plane. Thus the vector r dash of t gives both the speed and the direction of the plane. In other words, we can define the velocity vector of the plane at time t to be vector r dash of t. Similarly, we define the acceleration vector of the plane at time t to be vector r double dash of t. The acceleration vector gives the rate of change of the velocity vector. Now we can formally define the velocity, acceleration and speed of a moving object. Let vector r of t is equal to f of t I plus g of t j plus h of t k be the position vector of an object, and if f, g and h are twice differentiable functions of t, then the velocity vector v of t, acceleration vector a of t and the speed modulus of v of t of the object at time t are defined by v of t is equal to vector r dash of t is equal to f dash of t vector I plus g dash of t vector j plus h dash of t vector k, and acceleration a of t is equal to vector r double dash of t, which is equal to f double dash of t vector I plus g double dash of t vector j plus h double dash of t vector k, and the speed modulus of v of t is equal to modulus of vector r dash of t is equal to root of f dash of t the whole square plus g dash of t the whole square plus h dash of t the whole square. Now we can have some examples for finding the velocity, acceleration and speed of the given moving objects. Example 1. Find the velocity vector, speed and acceleration vector of an object that moves along the plane curve phi described by the position vector r of t is equal to 3 cos t vector I plus 2 sin t vector j. Velocity vector is vector v of t is equal to r dash of t is equal to minus 3 sin t vector I plus 2 cos t vector j, and the acceleration a of t is equal to r double dash of t is equal to minus 3 cos t vector I minus 2 sin t vector j, and the speed modulus of v dash of t is equal to root of 9 sin square t plus 4 cos square t. Here we can note that vector a of t is equal to minus vector r of t. So the acceleration vector is directed towards the origin here. Another example. Find the velocity vector, acceleration vector and speed of a particle with position vector r of t is equal to root t vector I plus t square j plus e raised to 2 t vector k where t greater than or equal to 0. Then we have the velocity vector v of t is equal to vector r dash of t is equal to 1 by 2 root t vector I plus 2t vector j plus 2 e raised to 2t vector k, and well acceleration a of t is equal to r double dash of t and is equal to minus 1 by the derivative of 1 by root 2 is 1 by 2 t raised to minus 3 by 2. So we have minus 1 by 4 t raised to minus 3 by 2 vector I plus 2 vector j plus 4 e raised to 2t vector k. And the speed vector modulus of vector v of t is equal to root of 1 by 4t plus 4t square plus 4 e raised to 4t. Now we can have another example. Find the velocity, acceleration and speed of an object with the position vector r of t is equal to e raised to t cos t sin t 1. So here velocity v of t is equal to vector r dash of t is equal to e raised to t cos t derivative e raised to t cos t minus e raised to t sin t, then e raised to t sin t derivative e raised to t sin t plus e raised to t cos t, again the derivative of e raised to t is e raised to t. Now modulus of v of t is equal to modulus of vector r dash of t is equal to e raised to 2t cos square t minus 2 e raised to 2t sin t cos t plus e raised to 2t sin square t plus e raised to 2t sin square t plus 2 e raised to 2t sin t cos t plus e raised to 2t cos square t plus e raised to 2t, and that is equal to the square root of e raised to 2t cos square t plus e raised to 2t sin square t is e raised to 2t, and minus 2 e raised to 2t sin t cos t and plus 2 e raised to 2t sin t cos t cancel, and again e raised to 2t sin square t plus e raised to 2t cos square t is e raised to 2t. So we have plus e raised to 2t, again the last term plus e raised to 2t, and that is equal to root 3 e raised to 2t. So this is the speed of the given curve. Now we need to find the acceleration. A of t is equal to e raised to t cos t minus e raised to t sin t minus e raised to t cos t minus e raised to t sin t e raised to t sin t plus e raised to t cos t minus e raised to t sin t e raised to t plus 2 e raised to t sin t e raised to t cos t e raised to t. Now we can sketch the path of a moving object in a plane with its position, with its velocity vector and acceleration. So for example, consider the position vector of an object in a plane given by vector r of t is equal to t square I plus tj, where t greater than or equal to 0. Now we want to find its velocity, acceleration and speed when t is equal to 2, and also sketch the path of the object and the vectors v of 2 and a of 2. So first we want to find v of 2 and a of 2. We have v of t is equal to 2t vector I plus j, and modulus of v of t is equal to root of 4t square plus 1, and acceleration is equal to 2i, v of 2 is equal to 4i plus j, and a of 2 is again 2i. Now we want to sketch the path of the object and also its acceleration and velocity at the point t is equal to 2. Here r of t is equal to t square I plus tj and t greater than or equal to 0. That implies x is equal to t square, y is equal to t, or in other words x is equal to y square where y greater than or equal to 0. So this is the path of the parabola. X is equal to y square where y greater than or equal to 0. And we need to draw the vectors v of 2 and a of 2 at t is equal to 2. Here when t is equal to 2, x is equal to 4. And we need to plot the two vectors here. Here we have v of 2 is equal to 4i plus j. So if we consider the vectors at the origin, it is of the form this form. So we plot that vector here. And A of t is like this. We have this is v of t 2 and this is a of t. When t is equal to 2, x is equal to 4. Like this we can plot, like this we can sketch the path of other moving objects and the given vectors. Thank you.